Well, good morning, pre-calculus students, and welcome to a new week. And so we're getting ready to start with our notes here for the new week. So we are going to start with 9.3. I forgot. We aren't starting with 9.3. We are starting with 9.2. So let's go ahead and let me grab the correct notes. And let's start with 9.2. There we go. All right, so we're looking at the binomial theorem. So I know you've had this in part before, but we're going to go a little bit further with it and be able to look at it. And in 9, we're looking at different ways of counting, and there are times where this binomial theorem doesn't just help us expand binomials, but also actually helps us count. So let's go ahead, let's start taking a look here. And let's look at, if we have a binomial, anything that's a binomial, a plus b. Remember, binomial, 2 terms. And then we're going to raise it to different powers. So we could raise it to the 0 power. That would be pretty easy to do. What would that be equal to? I think everyone can see that's equal to 1. Okay, that's not too bad. Then I can have a plus b to the first. Well, if I do that, it's going to be equal to a plus b. All right, so far so good. Now we start to get into a little bit more of a challenge, because remember, the tendency of students, the number one algebra mistake students make is saying that a plus b squared is a squared plus b squared. That is not true, or they make some variation of that mistake, like the square root of a squared plus b squared they say is a plus b. Calculus students do this all the time. It's a common mistake. But remember, this is a plus b times a plus b. So when we go a plus b times a plus b, we get that middle term, and we get a squared plus 2ab plus b squared. Okay, so not as nice, but still not too bad. Now, the problem is as the powers start to get higher, this starts to get more complicated. Because now what I have to do is I have to first take a plus b times a plus b and get this, and then I have to take this and multiply it by a plus b again. So I'm going to have a whole nother set of distributives. Not terrible to do with cubed, but it's starting to get kind of messy. When we do that, we get the a cubed plus 3a squared b plus 3ab squared plus b cubed. So then we can go on and let's go to the 4th power. Now we start to get really messy if we start to go to the 4th power. So what we want to do is we want to come up with a more efficient way to figure this out so we don't have to go through this whole process of expanding it out every single time. So what we're going to do, as we usually do, we're going to look for a pattern. Okay, and that's kind of what we're doing here with stuff is we're looking for counting, we're looking for patterns. And what we see is there is a pattern formed if we look at the coefficients of this. So this has a 1. Coefficients here are 1 and 1. Coefficients here are 1, 2, 1. Coefficients here are 1, 3, 3, 1. And if we kind of write that, you can see this is forming a triangle. And the triangle here, we get those first 4 rows of the triangle. And we can keep going with this triangle. The pattern continues. Now, interestingly enough, probably here some of you either remember or can see what this pattern, in this case, actually is, what this pattern is that's actually occurring here. What we see we're doing is to get each term, we are adding the 2 terms directly above it. So, for instance, this 2 was a 1 plus 1, this 3 was a 1 plus 2, this 6 is 3 plus 3, this 4 is 1 plus 3. So going to our next row, we should be able to see we'll start with 1. We always start with 1. We should get a 5, a 10. In between there's another 10, a 5, and a 1. Notice that we always have the same pattern going up and down. So once we get to the middle, we know how the rest of it goes. So we really only have to do half of a row, and then we've got the rest of it. So doing the next row, we would go 1, and we know we would go 6, 15, 20, 15, 6, and 1. Doing the next row, we'll see the next row there, and so forth. So this is Pascal's triangle. Now Pascal's triangle works very nicely if we don't have to go up too high with our expansion. Okay, so this right here, this one right here, if you want to keep track of it, probably the easiest way to think about it is if you're raising something, say for instance, to the 6th power, you need the 6th row, 1, 2, 3, 4, 5, 6, is one way you could, I said that wrong. You'd need the 7th row if you're going to the 6th power, okay? The other way you could, probably the easiest way to think of it though, is that if you're going to go to the 6th power, you want the one with 6 terms in it, would be another way to do it. So if you want to go to the 6th power, this is the row that you would want right here. That's probably the easiest way to do it, I think. I said that wrong again. I keep telling you the wrong thing to do. Sorry. If you want the 6th power, you need the one with 7 terms in it. So here's our 6th power row right here, because this is 0, 1, 2, 3. The other way to do it is to look at the second term in the row. The second term should match whatever you're raising it to. So if you want to go to the 7th power, you go here where there's a 7. 6th power here. 4th power here, and so forth. So let's look at AB to the 6th. So if we want the 6th power, we can go right here to this row. This is our coefficients. And notice the pattern that's happening with our exponents. The A, the first term, is to this power 3. And then notice the power of A goes down by 1 each time. So it's A cubed, A squared, A. And then this is actually A to the 0. Notice the B, the other one, is going up by 1 each time. It starts with B to the 0, which is just 1, so we don't write it. Then we have B to the 1st, B to the 2nd, B cubed. So we know that our first term here will have A to the 6th and B to the 0, and our first coefficient is 1, so it's just A to the 6th, plus. Then we look for our next coefficient here, which is going to be 6. We know we'll go A to the 5th, go down 1 there, and go B to the 1st. Then we go plus, look at our next one, 15. We see A to the 4th, B squared. Then we'll go 20. And we know we have A cubed, B cubed. And now we're just going to stair step our way back down. So we know it's going to go 15. And we're just stair stepping the variables in the same way. 6 and a 1, like that. So that's using Pascal's triangle. It actually becomes a good way to do something like this. Now let's go ahead and let's look at what happens when we have something that's not just A plus B. We actually have different expressions in there. So now we have a variable and a constant. So remember, this minus 2, we need to think of that as plus -2. That means our A, wherever we see A, that's actually X. And wherever we see B, that's actually -2. So since I'm raising to the 4th, I'd go up here and I'd look at the row that's got a 4 right here in it. Or I could think of it as being the one with 5 terms, or the 5th row. So starting here, I know I'm going to start with x to the 4th. Then I'm going to have a 4. So I'm going to get 4 times, and I know it's going to be x cubed. The x is going to go down by 1 in power. And now I have -2 to the 1st. That's just -2 to the 1st. Plus, then I got a 6, x squared, -2 to the 2nd. And now I'm already at the middle, so I'm going to go back down, plus 4. And I know it's going to be x to the 1st, -2 cubed. And then finally, it's just plus 1 times -2 to the 4th. Now, we're not quite done here, because notice these coefficients are constants, and these terms are constants because this -2 was a constant. So I do need to simplify the constants here. So I will have x to the 4th. Notice the x cubed term will be minus. It'll be minus 8x cubed. The x squared term here is going to be, this will be 4 times 6, so it's going to be 24x squared. Here we have -8 times 4, so we have -32x. And finally here we have plus 16. So that's using Pascal's theorem there, or triangle, to finish it off. All right. Now, the problem that we can get into is Pascal's triangle works great if I'm doing stuff like, to the 7th power, to the 8th power even, or 9th. But what happens if I'm raising it to the 13th power? Do we really want to have to draw out 13 rows of Pascal's triangle? The answer to that is pretty obviously no. And, what if it's to the 56th power? Now we got real issues. So we need a better way for when we're raising it to a much bigger power than that. So let's look at some notation that'll help us with understanding what to do. First, this NCR, remember this is combination here, the number of things combined for R spots. We can write that in shorthand as N over R in parentheses. There's no fraction bar there. It's not a fraction. It's just a shorthand way of writing NCR. Saves us some space, and we're going to need that when we look at our formula. So when we see this form here, we read this would be 6C2, like that. And so we know it would be 6 factorial over 2 factorial times 4 factorial, and it just becomes 15. All right. Let's go ahead, and now let's look at the binomial theorem. This is our way to do these expansions quicker than having to use more efficiently when the numbers are really big than having to use Pascal's triangle. So this works for raising this binomial to any power n. So we know the way this starts. This starts with a to the n. And what we're going to do, though, is this is actually a combination. Our coefficient is a combination of n to the 0. And we get a to the n. Notice this would also be times b to the 0. The key thing here is this top part here, the n in the NCR must match the power of a, and the r must match the power of b. So then I would go plus, and then I would go n1, NC1, a to the n minus 1. Sorry, I said that this must match this on the first one, but then these have to descend each time. So this is a to the n minus 1, b to the first. And then I'm going to go plus, and this is going to go NC2. And now this is going to go, now this has to go down by 1, so it's going to be n minus 2. So for instance, if n was 10, this would be a to the 10th, a to the 9th, a to the 8th. That's the way that works. And if this was 10, this would be 10 to the 0, 10C0, 10C1, 10C2, like that. And then we have our b squared. And we keep with this process. This process continues on until we go almost all the way down here. When we're getting all the way to down, we get n over n minus 1. So when we get n over just 1 less than n, that's when we have a to the first, b to the n minus 1. That still matches up with whatever's down there. And finally, we get n over n, b to the n. And by the way, n over n, that's just 1. Just like n over 0 is just 1. If you plug it into the formula, you will find out that's true. So that's how we get our coefficients of 1 at both ends. I know some of you are going to say, oh man, what if I forget the bottom number? Is it the power with A or is it the power with B? It doesn't matter. Because the way this formula works, it doesn't matter whether you call this 6C2 or whether you call it 6C4. That makes no difference. So here's the kind of problem we'll actually have to do. So we're not going to actually tell you to expand a plus b to the 20th, but we will ask you what the coefficient of the a to the 13th, b to the 7th term is in this. Well, the coefficient is going to be this leading part here. So I know that the n in my NCR must match the 20, and my r must match the 7. If you forget and you accidentally use 13, it works just the same, so it doesn't matter. So I'm treating this as, I know it's nr, a to the 13th, b to the 7th, so that means this is, n is going to be 20. That's always the power up here. And the r is the power of b, so we get this, 20c7. That's something I wouldn't expect you to do without a calculator. Anything that big you would get to do a calculator with. And we get 77,520. All right, here's another kind of question you'd have to ask. What is the x to the 11th term of x plus 2 to the 11th power? So now we just want to know that whole term. The term includes both coefficients and constants. So I'm going to go ahead. I know that the x to the 7th term is when x is going to be to the 7th, since this is to the 11th, and 2 will be to the 4th. because the powers there always have to add up to the total there. So I know this is going to be 11C4, x to the 7th, 2 to the 4th. So calculating 11C4, that's with a calculator I would do that. I get 330, x to the 7th, and 2 to the 4th is 16. Now I have to multiply this in my calculator, and I get that to be the x to the 7th term. Just so happens, that's how many feet there are in a mile. All right, 9.2, you will do 6 through 26 even. Okay, and pay attention to when it says to use Pascal's triangle or when it says to use the binomial theorem. Okay, you want to make sure you make that distinction. I hope things go well. We do have a Zoom session this afternoon at 12:45 for anyone that has questions. So I'll look forward to seeing those of you there. You should have noticed I did post your tests are graded and scored and entered in Family Link. By the end of today, I should have all the homework done as well. I kind of put the homework on hold while I was doing the tests. So that's all up to date. If you need, if you scored very poorly on the test and you want to talk to me about a retest, we will have a retest. I'll give it out more details, but probably my thinking right now is it'll be Monday. So sometime this coming Monday will be the retest. All right. If you have any other questions, join us in Zoom. All right.